This video is on graphing derivatives. First of all, before we can start graphing them, we need to understand increasing and decreasing functions. If when x increases and the function also increases, that means our derivative will be greater than 0 and the function is increasing. If we think about it, if x increases and y increases on a graph, it goes up this way, and we know the gradient of a line that goes that way is positive, therefore the derivative will also be positive. And then when x increases but the function decreases, our derivative will be negative because the function is decreasing. So if we think about that, x gets bigger, y gets smaller, our graph looks something like that, and we know the gradient of that line is negative. First example, for the following graph, determine the regions in which the function is increasing. So we want to know here, where is this function increasing? So all we want to know is when is the graph going upwards, and it's going upwards this point here and here. And so our graph is increasing when x is less than 1, and then when x is greater than 3. Because it's at the turning points that it stops increasing. Now, even though it doesn't ask for it in this question, we're also going to look at decreasing and stationary points because they are also important parts of the topic in calculus. So if we want to know where this function is decreasing, we're just looking for when the function's going downwards, which is between 1 and 3. So in this case, our function is decreasing when x is between 1 and 3. Then the other points that we can look for are stationary points. So this is when our gradient is 0. And we know our gradient is 0 when the gradient is horizontal, and it will be at our maximum and minimum points, our turning points. So our stationary points are when x equals 1 and when x equals 3. Example 2. Sketch the derivative of this function. Now the main thing when we're sketching a derivative is to remember we're no longer sketching x and y, we are sketching x and the gradient. So what is important in this is the gradient positive or negative, and that's going to tell us where to graph on the derivative graph. When I do this, the first thing I look for are the stationary points. So in this graph here we have stationary points here and here. The reason for that is the gradient of those points is 0. So on a derivative graph, that would be on the x-axis because the gradient's 0. So I'm going to plot those 2 points round about there. And so any stationary point, when we're graphing the derivative, goes to the x-axis. Now we need to look at where the functions are increasing and decreasing. Before the first stationary point, which I've just circled here, the graph is increasing, which means the gradient is positive. So that means on the gradient graph it has to be above the x-axis. And the only way we can do that is to draw it like that. Yes, the line's going down, that doesn't matter. All that matters is that this graph is above the x-axis because the gradient's positive. And if we think about this part, the gradient is getting less and less and less as we get to the stationary point, because we know the stationary point, the gradient is 0. So the gradient has to start larger, and the gradient does get less and less as we approach the stationary point, which is why the graph comes down. Now if we have a look at the next section, which I'm going to circle in green, which is between the 2 turning points, and we see there the gradient is negative because it's going down, which means on our derivative graph the gradient is negative, so it has to be drawn below the x-axis because the gradient's negative. Now the only way to be negative and join these 2 dots is just to join them. And then the last part of the function, which is after the second turning point, this bit here that I'm circling in blue, the gradient is positive once again, which means it has to be drawn above the x-axis on the derivative graph, and the graph will look something like that. Example 3, the graph shows y equals f dash x. So this is the graph of the derivative. Determine where the original function f of x is increasing, decreasing and stationary. So this is the graph of the derivative. So our y-axis is our gradient. So first of all, where is this function increasing? So remember, on our derivative graph, when the function is increasing, we know that's when the gradient is positive. So it's everything above the x-axis, which means that will be between 0 and 2, and also when x is greater than 4. Because that's all the points when the graph is above the x-axis. When it is decreasing is when the gradient is negative, so we're going to look at everything below the x-axis. So we'll have when x is less than 0, which is this bit at the start, and then when x is between 2 and 4. Now the stationary points, remember on the derivative graph, is when the gradient is 0, so we need to look at our x-intercepts, and we have 3. So our stationary points are when x equals 0, x equals 2, and x equals 4.